Learning combinatorics for the first time can be fairly tricky. So today my job here is to make it a little simpler and more intuitive. What is combinatorics? Combinatorics is the branch of math that focuses on counting possibilities. Hearing that for the first time, you're probably like, counting? Well, that's really simple. I learned that when I was 2 years old. And honestly, you'd be correct. Nothing about basic counting changes. Combinatorics just gives us smarter ways to count when the numbers get way too big to list out manually. Think of questions like, how many ways can we arrange? Or how many possible outcomes are there? If you're seeing these problems for the first time, you may have no clue where to start. Once you finish this video, you'll be able to approach questions like these much more naturally. So let's start with our baseline, factorials. If you've never seen factorials before, you're probably asking why these numbers are so excited. But this is just how we denote factorials. N factorial tells us how many ways we can arrange n distinct objects. So for example, 3 factorial is the number of ways we can arrange 3 distinct objects. But how do we actually calculate 3 factorial, or n factorial in general? Well, factorials are calculated by multiplying n by all its preceding integers down to 1. So here we have 3 factorial equals 3 times 2 times 1. And in general, n factorial equals n times n minus 1 times n minus 2 all the way down to 1. And for simplicity, 0 factorial is 1. Let's just say there's exactly one way to arrange 0 objects. Do nothing. Okay, let's build some intuition. Say we're given 3 people, Alice, Bob, and Charlie. How many different ways can we arrange them? Well, we could list them all out. We have Alice, Bob, Charlie, Alice, Charlie, Bob, Bob, Alice, Charlie, you get the gist. We have 6 total arrangements, which is exactly 3 factorial. But instead of brute forcing it, let's think about choices. When we're choosing to arrange the 3 people, for our first choice, we have 3 options, Alice, Bob, or Charlie. Now, on our next choice, after choosing one, we only have 2 choices left for the second position. Say we just chose Alice, we only can choose Bob or Charlie, and that goes for any one of the people we just chose. And similarly, on our third position, we only have 1 choice remaining. When we multiply these together, our total number of arrangements becomes 6, aka 3 factorial. And here is visualizing that idea using a tree. You see, for our first choice, we have 3 possibilities. Then for the next choice, we have 2 and then 1. And we can multiply these together, and you see at the bottom, we get 6 or 3 factorial. So in essence, that's factorials. Pretty much everything else in this video and pretty much a huge portion of combinatorics builds off this exact idea. Okay, now imagine you're a teacher with a class of 20 students and you're holding a singing competition to determine the top 5 singers in your class. And how many different ways can 1st through 5th place be awarded? For questions like this, we use another combinatorial technique called permutations. Permutations are typically denoted these 2 ways, and they have this formula, n factorial over n minus r factorial. That's cool and all, but where does this actually come from? Okay, so let's use the same logic as before. We want to fill 5 ranked positions. For first place, we have 20 possible students to choose from. Then 19 for second place, 18 for third, 17 for fourth, 16 for fifth. So our total number of outcomes is this number. And notice something important. Order matters here. Choosing your 5th position versus choosing your 1st position and getting 1st place versus 5th place are completely different outcomes. Now, this is exactly where we get the permutation formula from. Let's use a specific example. We can write 20 factorial as 20 times 19 all the way down to 1. But if you notice here at the end, this number is just 15 factorial. So if we divide by 15 factorial, everything else after 16 disappears, leaving us with just 20 times 19 times 18 times 17 times 16, which was our exact answer. More generally, permutations are calculated by this formula, where n is the total number of objects, or in our case, students, and r is the number of positions we're filling, like 1st through 5th place. So permutations are what we use when we're selecting objects and order matters. Okay, but what if order doesn't matter? Say we tweak our previous example. Instead of ranking the top 5 singers, we want to just pick any 3 students as finalists. No rankings, just the group itself. Well, initially, the counting looks exactly the same. We first have 20 choices, then 19, then 18. And we'd get 20 times 19 times 18 as our answer. But there's a problem. We're counting the same groups over and over again. For example, choosing Alice, Bob, then Charlie is the exact same group as choosing Bob, Alice, Charlie, or Charlie, Bob, and Alice, any ordering of the 3. These are different orders, but they're the same group. And the way we counted it cares about the orders. Since we don't care about the order anymore, these repeated countings are redundant. So for each group of 3, how many times do we overcount each group? Well, for every group of 3 people, there are 3 factorial ways to arrange them. So from our answer, we should divide out 3 factorial, because all we care about is one arrangement out of those 3 factorial ways. And this gives us our final answer. And this is exactly where the combination formula comes from. This represents the number of ways to choose R objects from N objects when order doesn't matter. You usually see it written as it is here, but sometimes also as NCR or CNR. When you read it out, you say N choose R. You may also hear this called the binomial coefficient, which shows up everywhere in probability and algebra. For example, how many 5-card poker hands can we draw from a standard 52-card deck? That would simply be 52 choose 5. Okay, simple. But before we move on, there's something I want you to notice. 20 choose 3 is the exact same thing as 20 choose 17. And more generally, N choose R is the exact same thing as N choose N minus R. But how does that make sense? Well, let's think about our example. If we want the number of ways to choose 3 finalists out of our 20 students, that's the same thing as choosing 17 losers or 17 students who didn't make the finals. Every time you pick 3 finalists, you automatically determine the other 17 non-finalists. So counting one is equivalent to counting the other. And algebraically, we see it in our formula. If we did N choose N minus R, we get the same formula as doing N choose R. And it's shown right above. They're literally the same expression, just written in a different order. Okay, now what if repeats are allowed? For that, we use something called the product rule, or the power rule. And honestly, this one is pretty intuitive. Let's say you forgot your 4-digit passcode, and each digit can be any number from 0 to 9. How many possible passcodes are there? We're still essentially using the same logic. For the first digit, we have 10 choices. It could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. For the second digit, we also have 10 choices. Repeats are allowed in passcodes. Same thing for the third and fourth digit. So the total number of possible passcodes becomes 10 to the fourth. Now let's say we have an 8-character password only using letters. Let's say every letter is lowercase, so we have 26 possibilities. If we want to see how many possible passwords there are, we use the same logic, and we'll get 26 of the 8 possible passwords. So to recap, factorials count the arrangements of all objects. Permutations count ordered selections, and we use combinations when order doesn't matter, so they count unordered selections. The power rule counts repeated independent choices. The whole trick of combinatorics is identifying which situation you're in, so once you know that, these problems become way less scary and so much easier. There's one more combinatorial method I'd like you to know. It's called stars and bars, but I'll save that for another video. Thank you for watching.